Hello and welcome to my channel. I am BeardedDev. If you are new to the channel, I produce videos on data engineering, business intelligence, T-SQL programming and data analytics. So don't forget to hit that subscribe button, and if you do want to see any videos in particular, do let me know in the comments below. In this video we're going to be looking at clustered index scan versus non-clustered index seek and a key lookup. So I'm just trying here a fun game, and it determines at what point does a clustered index scan become a non-clustered index seek. Short disclaimer, this is just a bit of fun, so we're not going to be looking at the number of pages and data size. It's just a game, and the beauty of this is you can experiment further with different data types and different sizes. And another thing to point out is within the insert statement, which you'll see shortly, is we are performing loops, which is bad practice in general, but in this case it makes life easier. Let's jump over to SQL Server Management Studio, and hopefully this will all make a lot more sense. Great, so I'm in SQL Server Management Studio now. For this video I will be using SQL Server. In the particular version I have is SQL Server 2019, and I use the latest version of SQL Server Management Studio. I've recently updated it to I think 18.6. So I'll just go through the script here. We are checking if table 1 exists. If it does, we're going to drop it. But most importantly is if we have a look at the create table statement. So we're just creating a very simple table that contains both a clustered and a non-clustered index. So it's going to be table 1. We have an ID column, so our clustered index is going to be based on our primary key. We have a value column, which is a tiny integer, and that's what we're going to use within our filtering for our testing. And then I have 4 basic filler columns, which are just string columns set to a length of 1. And I'm creating a non-clustered index on the value column. The query we're going to be using to do this, play this game or this experiment, is we're going to be looking at where value equals 1, but we're going to be selecting all columns from the table. So what that means is the non-clustered index we've created is non-covering. It can't use that index to return the values that we want to. So what we're simply trying to do is insert values into this table, and I'll go through the insert shortly. And when we run our query to look for a value equals 1, we're trying to check the execution plan, and we're seeing at what point, depending on how many rows we have in that table, does it change from a clustered index scan to a non-clustered index seek and a key lookup. Now, if you're not familiar with key lookups, they can be quite expensive, and that's what we're trying to determine here. Is SQL Server will probably choose a clustered index scan even if your query is quite selective on a small number of rows. If we think about clustered indexes, that's how the data is logically stored. So in a more practical example, imagine we're reading a book. We read a book from front to back. That would be how the data is stored. That would be our clustered index. A non-clustered index is stored as a B tree, and if you're not familiar with that structure, I do have another video on my channel, and I will leave a link in the description below, so feel free to go and check that out. So a non-clustered index is more so what we would consider the index at the back of the book, where we go to the index, we scan down and we search for something, and it tells us the page number to go to. Now, in our terms, it's quite fast to go to the index at the back, scan through it, choose our page number and go there. But we must remember that SQL Server is very fast at scanning data in order. So it's probably going to be choosing a clustered index scan more than we would imagine. So we wouldn't scan through, say, 300 pages in a book. We would just jump straight to the index to go to, say, page number 100. But for SQL Server, the way it structures the clustered index, it might just be faster to zoom straight through that data and find where the matches are. Now, as I've mentioned, this is a non-covering index. That means the non-clustered index doesn't include all of the columns we want to return. So what we will be doing is it will be searching that non-clustered index for the value equal to 1. It will then have to perform a key lookup to the clustered index to return the other values. The non-clustered index will store the clustered index, a reference to the clustered index, and that's what's called the key lookup. Without further ado, let's go ahead and have a look at how we do this. So I've broken this down into sections, and this script is available in the description, so you are available to completely follow along. And like I've said, feel free to manipulate this. This is just a bit of fun to get you a good understanding of clustered and non-clustered indexes, and at some point there will be a tipping point where a non-clustered index and a key lookup becomes faster than scanning all of the data, which is what we would expect. So first of all, I'm just going to insert a single row, and this is the row we're going to be searching for, so this is value 1. You'll notice that column A, B, C and D just had the same value of A. I've just put that in for ease. So if I go ahead and execute that, well, I should create the table first, so I'll create the table first. So I'll run the creation of the table, that's executed successfully, and we run our first insert. So we've got one row. Now within this query window, I must turn on the actual execution plan to see what's happening, what the database engine is actually doing. Now you can either press Ctrl M, you can click on Query, Include Actual Execution Plan, or there's a little icon here you can select as well. So remember, this table only has one row in at the moment, so we would expect it to be performing a clustered index scan at this point because it only has one row to read. And we open up the execution plan and we can see it's performing a clustered index scan, which we would definitely expect at this stage and certainly for the next few more inserts. So we're now going to go ahead and insert another value, and this is where I was talking in the introduction about looping. So I'm just using this because it's making life easier at the moment. So I'm just declaring a simple variable for the value 2, while that's less than or equal to 10, it's going to perform the insert. So it's just going to insert these values 10 times. So value 2, and then column A, B, C and D contain the letter B. So I'll go ahead and execute this insert. We've got another 10 rows inserted. Let's go ahead and execute this and check the execution plan. Now we have got a warning here that the column doesn't have statistics. That's nothing to worry about. It doesn't affect our game at this stage. It just means that the cardinality estimator can't produce a good execution plan. It hasn't got those statistics there about this table to produce what it would consider the best execution plan. Doesn't mean in this case it's not going to produce the correct execution plan because it has a clustered index scan. So we have 11 tables. We have a highly selective filter where we're looking for one row out of those 11. And I'll just do a select all to show you those results. So we can see we've got 11 rows. The majority of them contain the value 2, 10 of them, and one contains the value 1. So that's a highly selective filter, but we do have a small amount of data. So at this point SQL Server is still thinking scanning this data is still way faster than looking through an index and going through a key lookup. Let's go to our next value, which is 3. I'll just hide the results grid. So again, we're going to now extend it. So we're going to be inserting exactly the same loop, but this time we're going to be looping 100 times. And we're going to be inserting the value 3 and C into the character string columns. I've executed that now. That's all ran well and good. We should now see 111 rows in our table if my calculations are correct. So now the value 1 is becoming even more selective. But is it selective enough? Have we reached that tipping point of where it changes to the non-clustered index seek? No. Still doing a clustered index scan, and we still have a very small amount of rows. Now we move on to value 4, which again we are now increasing, and we're going to be inserting 1,000 rows with the value 4 and D in our other columns. If I go ahead and execute that now, although we're looping 1,000 times, generally that won't take too long. These are just simple inserts. Yes, it will be logging a lot, but it's not a problem. Again, like I've said, this is just a bit of fun. If you've got a database you can play around with that's non-production, definitely use that. Probably don't use this in a production environment. Okay, so now we'll have again 1,111 rows. So our filter's becoming even more selective. But have we reached the tipping point? No, we're still performing a clustered index scan at this stage. So we're going to go ahead as before, let's insert value 5, and we're now up to 10,000. So I'm going to go ahead and execute that. Don't think this will take too long, just took a couple of seconds during testing, 4 seconds to complete. We now have 11,111, so again our query is becoming even more selective. And if we execute the query now, have we reached the tipping point? Yes. So we know our tipping point with this particular data size that we're using is somewhere between 1,111 rows and 11,111 rows. Now you could take that yourself and go a bit further. You could narrow down those inserts and get closer and closer and closer, and you could also see if you could even go to the individual row that would cause that tipping point, because in this example we've got quite a wide range there of 10,000 rows, so that's quite a wide range of where that would go. But what I wanted to do was have a bit of fun with SQL Server. I like to do these different kinds of tests myself. I probably would have some fun narrowing this down further to see if I could narrow it down to the individual row where it would reach that tipping point. And one last thing I will show is the value 5. Well, value 1 is highly selective. We've got 1 row. Value 5 will be the least selective. It has the majority of rows. So let's change this to value 5 and run it. And we would expect a clustered index scan at this point. Because we're actually returning 10,000 rows, so what's that, almost, top of my head, 90% of the data, it would make sense to perform a clustered index scan. As I mentioned, these key lookups can be quite costly. We certainly wouldn't be wanting to run them 10,000 times in a table that contains 11,000 rows. So I really hope you have enjoyed that little experiment there. Feel free to change the data types here. I've used very small data types. Feel free to enter larger strings. I mean, the definitive answer to this all depends on data size and page size. So it's not just the column size. There are pages that are part of indexes that add on a few bytes each as well. But there are other queries you can run to see the size of those pages. But I thought this is quite fun, and it's something I like to do, to just play around with SQL Server and see how good it is and different things like that. Feel free to check out my other videos on the channel. As mentioned, subscribe to the channel if you haven't already, and hit that notification button to be made aware of when new videos are uploaded. Thanks a lot for watching.